This is a continuation of the factoring lesson. We have to try a couple of kinds of factoring that we haven't seen before. And so this next example is actually a difference of cubes. A difference of cubes is not something you ran into in Math 10 unless your teacher really did some enrichment, but the way that you factor it is you start off with an a minus b, and the term that's left over is you need a squared, you need a b squared, and the middle term here is just a times b. Again, you can try expanding that all out, and you'll find out that the fact that you have a minus in the first bracket and pluses in the second bracket means that all the middle extra terms cancel out, and all you end up with is a cubed minus b cubed. Very much similar to a sum of cubes, which factors, first of all, is a plus b. You still have an a squared, you still have a b squared, but the only way things will cancel out in the middle is if I have minus ab in the middle here. So let's do an example of each one of those. If I have 125x cubed minus 729y cubed, they might not, off the top of your head, you might not realize that those are both perfect cubes, but they are. So you have, again, a difference of cubes, and the cube root of the first one is 5x, the cube root of the second one is 9y. It's a difference of cubes, so I put a minus in here. If I square the first term, I'm going to get 25x squared. If I square the second term, I get 81y squared. The middle term is just the two things multiplied together, so 5x times 9y is 45xy, and that would be good factoring for the difference of cubes. Now, sum of cubes is kind of unusual, because if we had a sum of squares, we always said does not factor, and we'd be stuck. So, for example, if I had 16a squared plus 9b squared, I'd be stuck here. No common factor, nothing to do, so I say does not factor, I'm stuck. This is as simplified as that thing's going to get. But with a sum of cubes, you actually can take it further. So let's say we had 8a to the 6th plus b cubed. Well, if you recognize each of these as a perfect cube, the first one, the cube root is 2a squared, second one, the cube root is b. It's a sum, so we put a plus in the middle. First term squared is 4a to the 4, second term squared is b squared. Those two terms multiplied together, 2a squared b. There was a plus in these first brackets, so I need a minus in the second brackets. And you have yourself a factored sum of cubes. Something you didn't run into in Math 10, but you will see the occasional cubes in calculus, so something to practice.